Okay, you should have the notes for parabolas as conic sections. And would you please put these right after the notes from yesterday, equations of circles. So these new notes for parabolas as a conic section, or as conic sections, should be right after that. We're going to start off today reviewing some information from semester 1 and parabolas. We looked at parabolas in several ways. We're going to start with this y equals x squared, this nice basic parabola. I am going to be going kind of quick today, so if you need to pause the video and rewind it a little bit so that you can get all the information down, then please do so. All right, our basic parabola started right here at 0, 0, and then we followed that 1, 4, 9 pattern. So over 1, up 1, over 2, up 4, over 3, up 9. This one only goes to 7, so I could estimate, but then I'm running into my words. It's close enough just to do that many points. And then on the other side, over 1, up 1, over 2, up 4. And then we go ahead and sketch in that nice parabola shape. Then we looked at what happens when we put a constant in front of that squared quantity. And a constant in front here does a vertical stretch. Vertex is still at 0, 0. But this time we're going to take our y values and multiply them by 2. So over 1, up 1. But this time we're going to go up twice as far because that's a 2. So when we go over 1, we're going to go up twice as far as we normally did. So it's going to go up 2. Over 2 would go up 4 normally, but this time because we want to do that stretch, we're going to go over 2 and up twice as far, so up 8. We are going to have to estimate on this one. It's going to be right about there. On the left-hand side, following that same pattern, over 1, up twice as far, over 2, up twice as far as we normally did. And this makes the parabola skinnier because in effect what we've done is take these points over here and we've pulled them up. We've stretched them up vertically. All right, on this one, we have some numbers inside the parentheses and numbers outside. This shifts the parabola. Numbers on the inside are going to shift left or right. In this case, we go right. Remember, it goes, if it's on the inside of the parentheses, we go opposite direction of the sign. So -2 in here means we're going to move to the right 2. Numbers on the outside parentheses, we do the same direction as the sign. So this -3 here tells us we're going to move down 3, which sets our vertex at to the right 2 and down 3. Normally at 0, 0, right 2, down 3, puts our vertex at 2, -3. And then we follow that same 1, 4, 9 pattern. So over 1, up 1. Over 2, up 4, over 3, up 9. We can fit it this time. 2, 3, 4, 5, 6, 7, 8, 9. And following that pattern on the other side, and here's our parabola. All right, this one's got a whole lot of stuff going on it. Just like this last one that we did, this is going to shift us to the, this time because it's +1 in there, we're going 1 to the left. And this +4 out here, we're going 4 up. That sets our vertex at -1, 4. Now, the half here tells us that we have a compression. And the negative part in here tells us that the parabola is going to open down or upside down. Lot going on in here. All right, vertex at -1, 4, right here. And then normally we would go over 1, up 1. But this time, because of the half compression, when we go over 1, we're only going to go a half. And then because of the negative, we're not going to go up, we're going to go down. Over 2 would normally go up 4, but this time we're going to go down half as much, so down 2. Over 3 would normally go up 9, but this time we're going to go down half as much, so down 4.5. I think we could even get the next one. 4 would normally go up 16, because 4 squared is 16. But this time we're going to go down half as much, so down 8. 2, 3, 4, 5, 6, 7, 8. Very good. All right, let's copy this on the other side, following this pattern. And then sketching that parabola in. Hopefully this stuff is sounding familiar. Again, if I'm going too fast, please pause the video, rewind it, and catch up. Listen to it again if I'm going too fast. Flip the page. A few more things we looked at, and then we start with new stuff. All right, sometimes our parabola was in factored form, and when that parabola is in factored form, this identifies some intercepts. There are x-intercepts at, from here, 4, 0, and from this one, opposite of that sign, -2, 0. So we can plot those points at 4, 0, and -2, 0. Leading coefficient here is a 1. That tells us it's positive, so that tells us it's going to open up. And we know that the vertex is halfway between the x-intercepts. So halfway between -2 and 4. You're finding the midpoint, so add them up and divide by 2. -2 plus 4 is 2. Divide by 2 is 1, so your x-intercept is going to be at 1, comma something. Now we know it's going to open up, so it's going to be doing this somehow. We just don't know how wide it is. So take that 1, and we're going to plug it right back up here into this original equation. Put a 1 in here, and that gives us a -3. Put a 1, put a 1 in here gives us a -3. Put a 1 in there gives us a 3. -3 times 3 is -9. There's your vertex. We are going to have to estimate here. 7, 8, 9. All right, now you can just go ahead and draw that in, but we can get some more nice points because we know that coefficient's 1. So from here, over 1, up 1, it follows at 1, 4, 9. Over 2, up 4. Over 3, up 9. Oh, and look, it hits that point very nicely right there. Sketch in that parabola. And there we go. Okay, number 6. This one's in standard form right now, but we probably we can either put it into vertex form, but it might be easier if we put it into factored form. And two parentheses here, x here, two numbers that multiply to be 24, add to be 10. That's going to be a plus 6 and a plus 4, which gives us x-intercepts at -6, 0, and at -4, 0. Remember, in the parentheses, opposite sign. So -6, 0, -4, 0, right there. We know the vertex is halfway in between. That's going to be at -5, comma something. Plug a -5 in, and it's easier to plug the -5 into the factored form. -5 plus a 6 is 1. -5 plus a 4 is -1. 1 times -1 is -1. Oh, and we see we start in at 149, so we can go over 2 and up 4. And that'll give us another set of points. Just skip, oops, I'm off a little bit here. Just sketch that parabola in. All right, we did all of that first semester. Now, there's another way to look at parabolas. And we talked about this on the cone as a conic section. As a conic section, a parabola is defined as the set of all points in a plane, so on a flat surface, in a plane that are equidistant from a given point and a given line. That given point is called a focus. That given line is called the directrix. If you grab a ruler here, my diagram sadly is off a little bit, and I didn't have time to fix it before I had copied your notes. So we're just going to have to use our markings here. This point right there, there's the given point, that's the focus. This line down here is the directrix. So this definition says any, I can't talk right now. Somebody just came in the room, and even though I have a sign on my door that says, shh, recording, somebody still came in. That's okay. That's okay. No worries. All right, so if you were to connect that focus with any point on this parabola, maybe that distance right there, that point, and then you take that point and you drop a perpendicular down to the directrix. I'm going to line up my tick marks here. This and this are the same length. Those two things are the same length. So that point on the parabola is equidistant, same distance from the focus as it is from the directrix. If we choose a different point, maybe I choose this point up here. That distance from that point to the focus is the same as the distance from that point to the directrix. Those two are the same. Any point on this parabola. Oh, let's choose, how about this one, the vertex right there. From the focus to that vertex, and from that vertex to the directrix, those distances are exactly the same. When we look at a parabola in this form, we can look at standard form of a parabola. Different books use different things. Well, standard form of a parabola, which is actually a small variation of vertex form of a parabola investigated in this way, is the following. So, all right, let me try that again. The standard form, which is a small variation of the vertex form of a parabola, when investigated in this way, looks like this. Y equals 1 over 4p times x minus h squared plus k. The hk still tells us the vertex. This whole fraction, 1 over 4p, that's what used to be the a. It tells you whether there's a vertical stretch or compression, and it tells you if the parabola opens up or down. This p is what's new, and that p is the distance from the focus to the vertex, and it's the distance from the directrix to the vertex. A lot going on in here. Let's go through an example and see if that helps clean it up for you. So, for these next problems, I want you to graph the parabola, identify the vertex, the focus, the directrix, and the endpoints of the lattice rectum. You don't know what this is yet. That'll come up when we do the problem down here. So let's look at this. We want to take this equation and we want to rewrite it as in this form that's up here at that top, that 1 over 4p. So, first thing, some of you can see it already, but if you can't, take this 1/8, and we know that that's got to be in the place of that 1 over 4p. That 1 over 4p is going to be equal to 1/8. If we cross multiply, we'll get 4p is 8, which means p is 2. Because that p value is positive, this parabola is going to open up. The vertex is at 0, 0. We didn't add or subtract anything in here. So let's start there. The vertex is 0, 0. Now, instead of using our 149 and then having to do a 1/8 compression, that's hard to do. We're going to use this new focus and directrix idea to get this idea of this parabola, how big it is. So P is 2. Here's the vertex. We know it's opening upward, so it's going like this. P is the distance between the vertex and the focus. So I'm going to put up 2. There's my focus. Down 2 is this line, this directrix. There's the directrix. So right now we can fill in. We have the focus, and the focus is at 0, 2. The directrix, that is a line. It is a horizontal line, so it is y equals -2. All right, one last thing that we have to get is something called the endpoints of the lattice rectum. So what we're going to do is we're going to take this p value and we're going to double it. So 2 times 2 is 4. From this focus, then we're going to go out 4. 1, 2, 3, 4. Right there, and then go 4 the other way. 2, 3, 4. that segment right there, one, it tells you how wide to make this parabola, because the parabola has to hit those endpoints. This segment right here is the lattice rectum. The distance on either side of the focus is 2p. So when we look, our endpoints of the lattice rectum are at 4, 2, and at negative 4, 2. I know this is a lot of information, and just be patient. We're going to do another couple of examples, and hopefully that will clean up your questions or issues. Okay, flip the page, and let's go right here and look at number 4. All right, lots of stuff going on in here. First off, I see my vertex cleanly right here is a 2, negative 1. Yes, 2, negative 1. There we go, right there. There's your vertex, just like it was before. Take this part right in here, this coefficient, this 1/12. 1/12 equals 1 over 4p. Cross multiply. 4p is 12. P is 3. P is positive, so this is going to open up. All right, now we know it's doing something like this, right? It's opening upward. The focus is 3 units up from that vertex. I always like to label my vertex and my focus so I don't get them mixed up. Up 3, so 1, 2, 3. There's the focus. That's at 2, 2. The directrix is 3 units down, p units down, so 1, 2, 3, and it's a horizontal line. Right there. And that is at y equals negative 4. All right, now, endpoints of the lattice rectum. Again, from the focus, we're going to have to do 2p. So 2 times 3, which is 6. And we go out either way. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right there. That tells you how wide to make this parabola. Right there. So they were at negative 4, 2. And at 7, 2. Okay, let's look at another one. Last one for today. Okay, vertex. This coefficient out here is going to tell us what the p is, so I don't need that one. There's nothing added or subtracted inside parentheses here, so there's your 0 for the x-coordinate, and this plus 4 hanging around on the outside gives us our y-coordinate, so 0, 4 for that vertex. Come figure out what p is, so we're going to take this coefficient. Negative 1 over 6 equals 1 over 4p. Assign the negative sign out here to the numerator. So when I cross multiply, I'm going to get negative 4p is a positive 6. divide out that -4. 6 over -4. Simplify, so we have -3/2. Okay, that's the distance from the vertex to the focus. Here's the vertex. Oh, one more thing. P is negative this time, so this is going to open down. So we know this parabola is doing something like this. We're just not exactly sure how wide it's supposed to be. Okay, so to the focus then, 1.5. 1.5. There's the focus. And 1.5 up from the vertex then, this way. And we know that the focus and the vertex are reversed now because P is negative. There's the directrix. Let's jot this stuff down. Focus is at 0, 2.5. Yes, you may write 2.5 if you prefer. The directrix, horizontal line at y equals 5.5. Okay, endpoints of the lattice rectum. Let's see, from the focus, 2 times that. 2 times 1.5 is 3. So from the focus, 3. 1, 2, 3. 1, 2, 3. And that tells us again how wide to go. And there we go. Let's see, this one is at 3, 2.5. And this one is at -3, 2.5. Okay, hopefully by the time that we got to that last one, things were starting to fall into place for you. If not, please go back and watch the video again. It's okay to do that, really, it is. Your homework for today is a worksheet. There are 4 questions on it, so hopefully we do okay. All right, thank you very much for tuning in. See you tomorrow.